Good afternoon and welcome to the presentation of AT Sensors. Yes, with a long title, XCS, incredibly fast and ultra high resolution 3D laser triangulation sensor. XCS is standing for Extreme Compact Sensor and is one of our high-level sensors, which is especially developed for electronic and semiconductor market, because there you need a high speed, you need a high precision and a high accuracy to detect really small components. But it's just one topic which I want to introduce today. I also want to give you an overview of our portfolio of 3D sensors. And yes, the 3D sensors are providing the 3D images, the point clouds, and also I want to introduce the metrology package. It's really helpful tools from calibration in transport direction, multi-sensor calibration, so to get maybe one point cloud out of a few sensors. And then there are also some tools to make a completely metrology application. So compared to the former presentations, we have just components, I would say. And these components are not smart sensors. We have always PC-based sensors and providing the image. So my name is Armin Jehle. I'm Senior Sales Manager at AT in Europe. And yes, so I always mention I'm nearly 25 years in machine vision area. A lot of the time at Cognex, but also I was working for a system integrator and another 3D vendor. And yeah, the last 10, 15 years, it's got more and more important to have a 3D solution. And so at that time, I always were looking to AT, because AT has what I need for projects, for customers, in terms of more speed, of more resolution, of dual head sensors. And so I was always were looking to AT because they have what I need. So since 4 years, I'm part of AT, and yeah, now I'm happy. So a few words to AT. Peter always mentioned it. So we made a rebranding because automation technology is really long. And in the past, we also had infrared turnkey solutions. So now we are focused more on sensors in infrared and as well as in 3D. So we do a rebranding, and now AT automation technology is AT Sensors. So don't be confused. It's not a new company. You find these AT sensors as a logo on the products as well on the new website, atsensors.com. So a few words to AT. Maybe you heard from our marketing team in videos in LinkedIn. They also start with hello from Bad Oldesloe. Bad Oldesloe is in northern Germany between Hamburg and Lübeck. So, and yes, we are more than 25 years on the market. And now we are nearly 55 people. And we're developing, producing, selling special cameras in two areas. One is the infrared, that we provide a special smart camera with a job and app concept. But today we want to talk about a 3D solution. And therefore we have just 3D sensors, just PC-based and only triangulation sensors. So some benefits, some advantages of AT. Yes, you see, yeah, once AT, always AT. Yeah, we have really a big portfolio and modular compact sensors. So if the customer is using the sensor, normally is satisfied and have maybe the best what he can get on the market. The reason why is that, so we always have the fastest sensors. Yeah, you see here maybe up to 200 kilohertz with our 1280 pixel sensor. And also maybe you heard the warp speed. Warp is standing for widely advanced rapid profiling. What does this mean? I have some other slides here in the next time. So we have a big range of different images from 1280 pixels, 2000, 3000, 4000 pixels, and especially yes, 3000, 4000 pixels you need for high accuracy, also for high precision measurement and metrology. And for laser triangulation, yeah, we have different lasers, but not only different wavelength and laser class. Also, we look for the laser line thickness or for the depth of field of the laser to have really the right sensor to get the best results of the application. And as well, yes, we have single dual head sensors. And maybe you see on the right side some images or some products. So we start with the camera. We have just cameras in with all resolutions, with all images. If you need maybe a separate laser, therefore you have to do the calibration by your own. This is maybe for bigger distances, field of use, like road scanning, where I need also a sensor or laser with more power than milliwatts. And then we have a big portfolio, so nearly 35 different sensors from 7 millimeters field of view up to 1.3 meters. and is multiplied by the different laser options which are available. So it's more than 150 different sensors. If this is not enough, and we have our modular compact sensors, and there we have another slide in the next information. So we're starting maybe with the low end. It's called ECS, it's economic compact sensor, because we have some applications or industries where we need maybe some easier applications, some easier sensors, and therefore we have a cost-effective series. We have here two sensors with 2000 pixels. It's also nearly 25 kilohertz, so not really slow, but only with the lasers in 660 as a red 660 nanometers with 2M lasers, because in industries like food or like logistic, it's much easier to use a 2M laser. Therefore, you don't need any laser safety actions. This sensor is available with 100 and 160 millimeters field of view. And yes, for sure, it's the same connection, the same standard interface with GenieCam as the other sensors as well. Few weeks ago, we introduced a new ECS series, so means with 4069 pixels, because we have applications where I need a bigger field of view and a little bit more resolution. So the sensor says as well also only the red laser with 2M, and field of view is 284 and 575 millimeters, because especially in logistics, maybe you need more than one sensor. You want to do not only the position of the package, you also want to have the volume, do some measurement, also maybe some surface inspection if there are some defects. And yes, in this case, maybe you see, we talk about maybe applications where we need maybe a resolution of maybe 0.5 millimeter, not microns. So therefore, the red laser is a little bit brighter, therefore a bigger laser line thickness. So they don't care about the application. It's absolutely okay for that. But for metrology applications, yes, we recommend our other standard sensors. And here, yes, you see you have two sensors. And with our metrology package, it's quite simple to do a multi-sensor registration and to get one point cloud out of two or more sensors. I have some other slides later. So this was the entry level, the ECS. So go to the high level. And yes, you know, normally you have an imager, you acquire an image and you transfer all pixels from the imager to the FPGA on the sensor. This needs some time. In this case, is a sensor with or imager with 3000 pixels developed by AT, and yes, for sure, produced for AT exclusively. And the special thing is there is a pre-processing, and maybe you see in this graphics, we just detecting on the imager the laser line, and only we are transferring the pixels around of the laser line. This is 20, 30 times less information, and yes, 20, 30 times faster. And this new imager with 3000 pixels in combination with our new FPGA of C6 series, which have double speed, and in combination with our new I/O interface boards, we have 2.5 and 5 gigabit per second, because you have to transfer all information from the sensor in time to the PC. This is what we are calling warp speed, widely advanced rapid profiling. And this new imager with 3000 pixels is also available in our modular compact sensors. This is really what we have, all resolutions, all images, all optical setups, all lasers we can put in and create your own sensor. Here's one example. As a dual head, here you can see two sensor modules and one laser module, and depending on your specifications you need, there will be no link module between, or a metal or maybe a carbon tube. And how does this work? So you see here, yes, is one example. We have a sensor module with the imager, with the Scheimpflug optics in, and as well in the laser. And you have an MCS configurator. There you can insert the specifications, what you need, like as the field of view, like the working distance, triangulation angle. And then out of the configurator, there's a sensor coming out. Here you can see is a single head. If you press double, you will have two sensor modules. But at the end, you have a customized 3D sensor. Customized sounds really expensive, but it's not. So we have no additional engineering costs, no minimum order quantity. But at the end, you get the optimized sensor for your application. So out of this MCS sensor. We provided also a standard sensor, and now we are, yes, at the title theme. The title is XCS, is an extreme sensor. This means we optimized a modular compact sensor in optics. So we are using the 3000 or the 4000 imager. If you need speed with warp speed, yes, for sure, this is the 3070 warp sensor, but high resolution on a really small X field of view. So for the 3000 pixel sensor, we have 48 millimeters. For the 4000, we have 53 millimeters. And also with the special optics, we get really a high precision on really sensors for the electronic market. And this is one part, the optic, but another one is the laser. And there we choose a really laser with a clean beam technology, 4 or 5 nanometers, 3R, which has really a thin laser line. Because we have to detect, as you can see in this image, boycott areas or pinprick areas, and the pins got smaller and smaller, and you need a lot of pixels to really detect the height and get really a good image. Therefore, we need really a small, good laser. And also, we have to avoid here occlusions, because maybe there could be a shadowing. Therefore, we have a dual head available, as you can see here. And also, yes, the reflections on the edge of the pins, so we can avoid that with a really thin laser line. So this is more or less a rough overview and a short fixed overview of our portfolio from the ECS up to the XCS. And yeah, with the sensors, we are providing the 3D images. Could be intensity image, could be range map, reflectance map, scatter map, but also the point clouds. And in the past, maybe, yes, this was it. We had an image, and then you start with your own vision library with third-party libraries like Telcon, Cognex Vision Pro, Matrox, and other stuff. And our customers are doing the complete solution. Now we have much more. We have our solution package with the metrology package. And with this metrology package, there's not only the calibration parts, but also 3D tools. And our customers can do their complete solutions with the software and with the sensors. But I want to mention again, so we are providing just the 3D sensors, which are connected to the PC. We are providing the software stuff to do a solution. But yes, we need still some 3D experts to do a complete turnkey metrology application. How does it look like with this metrology, with the solution package? So there are the standard software or SDKs available. There's the online documentation, and as well as the metrology package. And this metrology package has some really helpful tools. One of those is the Metrology Explorer. You can see it here. Now, it's a really easy graphical user interface. You see directly which sensors are available in the network. You can connect to a sensor, and then you have all parameters which you need to acquire an image really fast, like its exposure time, gain, maybe the trigger signal, the encoder signal. And that's what we say, yes, to get really fast within 10 minutes a first image. If you can see the defects, if you can see what you want to measure, it makes sense to go further on and then to start with developing the application. This is the Metrology Explorer, but we also have a lot of samples for metrology. You can start with the sample to develop the application. We have 3D tools available. So, and the target is to have really a fast prototyping and a short development. And yes, as I said, we have always also 3D point cloud processing tools that you can do a complete application. If you need the source code and you start with the 3D points tools, then there is a development license necessary. If you only need maybe the Metrology Explorer and the calibration, so we don't need a license. Really important is the calibration and the multi-sensor registration. So our sensors are factory calibrated along the laser line, means lateral, but you need also calibration in transport direction, in Y direction. So therefore, it's quite simple to use maybe some sample, some target samples, or for multi-sensor registration, yeah, like you see here, as a V, or for example, as a dual head, you have two cameras, we have two images, and you get 2 point clouds. And in this case, you see it as a V. We have 2 point clouds, and it's quite simple with the metrology package to get 1 point cloud out of 2 sensors, or 4 sensors, or more. And this is a really important tool, and everybody who is developing maybe a calibration or maybe do some coordinate systems, maybe from the camera to the robot, knows this is really complicated. Here it seems really easy. It's easy, and our customers can use this tool, or they say, no, I just need a point cloud. I do it by myself. So here's some really also helpful tools to see some calibration targets in different field of use. What you need for the sensors, you can use that. You can buy that from us, or you can use other samples. And here's some applications. Maybe if you visited our booth at the Vision Trade Show, we had a free fall demo with golf balls. And in this case, yeah, we had 4 sensors. Yeah, you can imagine the speed of a free fall, but here we just used the 1280 pixels. It was for speed enough. We don't need a warp speed. And we had 4 sensors with 2 different laser colors. It's in blue and in red. And then you see the result. Here you see the point cloud out of 4 sensors of the golf ball. And we also had the opportunity to insert some chocolate bars. And here you see also from each sensor is a different color. So at the end, you see a point cloud from 4 sensors. So it's quite simple. It seems simple, but yes, it's done with our methodology package. Another example, also from our trade show, it was pin area inspection. Really, you see really thin pins. And we do that with our XCS, with the dual head, because here they have some occlusions. And here you see the point cloud. And also with the metrology package, means we have used the tools to measure the height of the pins. And here you see some in red. Yes, the height was not correct. It was higher than expected. And you can imagine, to get really these thin pins, it's necessary to have a thin laser line. And we achieved that with the clean beam technology and have a laser line thickness of just 23 microns. So there's a video from that. See that? So this was from the trade show. I also have some examples from the field with our partner SenseWork. You saw at Wenzel and so on, you see the CMMs with offline metrology. So we do not provide sensors with Renishaw adapter. So we are more in the area of inline metrology. And this was here also the application to do that. We optimized the modular compact sensor. In the field of view and distance, we are using 2 different laser wavelengths, also with nearly the same laser line thickness with the depth of field of the laser. And then with 4 sensors, you get 1 point cloud out of 4 sensors with the methodology package. Here you can see the point cloud, and this point cloud is compared to the CAD data, and you see some flags where you see the measurement tools for MSR. And in this case, they need just maybe 8 seconds to do the completely application, to do the check of 1 part. With the new C6 series, yes, you have half time. You also can do the application and the measurement within 4 seconds. This was from our partner SenseWork. We have another application from our partner AKU. AKU is using their Vision Manager. This is a framework where you also can get maybe 1 point cloud out of from several sensors. Then they're using third-party libraries like at Helcon, Vision Pro from Cognex or Metrox. In this case, it was necessary to have a gear part. You see the calibration part which they developed, and it was a 360 degrees measurement. Means we need 3 sensors with 2 cameras, means 6 cameras to get really a nice image of the completely part, and 1 point cloud out of 6 sensors. So this was really a fast and rough overview regarding our products, regarding the software. And if you have some questions, yeah, we can start now.
We have already a question. It's about what is the largest part you can measure with 1 sensor. I saw at the dual head there was something about 1,800 millimeters.
Yes, we have our standard sensors from 7 millimeters up to 1.3 meters. With MCS, you can nearly 1.8 meters, 1.9 meters, and the distance is up to 2 meters. So this is, yeah, the target are our calibration tools in our production. Yeah. But yes, if we need bigger field of use, as I mentioned before, we have just the cameras. It's also for road scanning. Then you have maybe a distance of 5-6 meters and maybe a field of view of 3 meters. No? You can do that. But depending on the quantity, yes, maybe we can expand our or extend our calibration methods, and we also can do that. No?
And
yes,
how many sensors could you add together if you have larger or broader parts? For the
so we do it in the metrology
360.
package. It's up to 8 sensors. What we've done in the yeah, for applications, but I guess you can do also more. But it's depending. Also, you need the power of the PC and to get all information to the PC. So it's also need the right PC in the background. No, but yes, with 8, it's not a problem.
And how is the metrology package working with 3D party software? Or 3D party
So
vision
yes,
software?
as I mentioned, you can just get a point cloud, and some customers say I only need a point cloud. I have my 3D software or my own software. But if you want to use maybe just the calibration tools to get maybe one point cloud out of more sensors, it's also helpful. You can use the metrology package. Don't have to use a development license, and then you send this completely point cloud to the third party software.
Armin, thanks a lot.